about this area element. Okay. This area element here, this one.
Yes, sir. Sir, it is looking like a pie, sir. Part of pie, sir.
Okay, that same central angle it is making, but at some variable distance from the center. This small r is now variable, and capital R is the fixed radius or that constant radius of this circular sector or a part of this circular sector. We need to find out. Now, we can consider for a very small value of dr, this is a line or a circular arc. And for this circular arc, this is the corresponding value of the centroid. And what about the distance of the centroid of this individual element? That we get from the previous calculation, 2r divided by alpha multiplied by sine half alpha. So in that expression integral x dl, integral x dA over integral dA, this is the relation. dA is r alpha dr. R alpha is the length. This length is r alpha, and thickness of this line is dr. So r alpha multiplied by dr, this is the area of this element, right? And individual centroid of this line element is here. Distance of this centroid of this small element, it is area element, but we are considering for a very small value of dr. It is
Sir, screen is stuck.
Screen is stopped.
Yes.
Don't you find any pen movement there?
No, sir, it's stuck in.
No, sir, pinta atke ache.
Now is it reflecting something?
No, sir.
No, sir, ek hi jagah
No,
ache.
sir.
No, sir.
Now is it happening for everybody?
Yes, sir. Yes, sir. Sir, yeah.
Yes, sir.
Yes, sir.
Yes.
Pen is not.
Yes, my screen is what? Maybe some
Pen is
disturbed
not
network
moving.
issue.
Now it is visible, sir.
Now?
No.
Yes, sir, visible.
Now it is visible,
Visible?
sir.
Yes, sir,
Okay.
visible.
Yes.
So this expression dA, the area of this small element, it is length of this multiplied by width of this dr. So r alpha dr. This is variable area. A very small value of this area element. And what about the location for the individual centroid for this line element like thing? 2r by alpha, the previous expression. 2r by alpha sine half alpha. And you complete that integration for the range 0 to r for this variable smaller, and you get this expression. Now, if you want to check it, you can have some quick look on this integration. You can do it. R alpha gets cancelled. Only one variable r is there. One alpha as constant in the denominator. Then integration of sine half alpha dr, etc. So when you integrate, it comes in this form. But I think some mistake is there. That is, this r is variable here. Now, after integration from 0 to capital R, it will be 4 capital R divided by 3 alpha sine half alpha. Okay. So please check there and make a note for this expression. So after integration small alpha, it becomes to be the range of the integration capital R. Okay. Is it fine now? And
Yes,
this expression is very important. Very important. We must remember these two things. One is 2r by alpha sine half alpha, and that is for a circular arc. Other is 4r divided by 3 alpha sine half alpha. Very important. Now next thing, we can adopt some other method to find out the location of the centroid. That is here in that alternative approach. What is that alternative approach? We consider one area element instead of line element. We consider one area element. It is in the form of a very small width triangle whose base is rd theta. Its position is at any variable angle theta, and this radial deviation is d theta for these two sides of this triangle. So once we consider this triangle, then at this 2/3 location, we have that centroid of this area element. So this is the x distance for element. Is it okay? Yeah.
Sir, your slide is not visible, sir. Your slide is fixed. Fixed
sir.
at,
Sir,
at the line element part. Element part.
On my screen, it is showing bad network quality. If the sound quality is bad, check your internet connection and try. So now I think it has disappeared, that message. Now is it clear?
No,
Getting
sir.
some.
No, sir.
Same, sir.
Your voice is clear, sir, but sir, the screen is freezed.
This screen.
No, nothing changed, sir.
The screen
I'm
is
writing.
free.
Pen is also not moving.
I don't understand what is happening, but here in my system, it is showing the current screen. Is it same for everybody? Or what I can do, I can
Just scroll one.
Rejoin, sir. Rejoin.
Black, sir.
Rejoin, sir.
No, I will not rejoin. I will just de-share this file and then share this file again.
Yes,
okay. Stop
Okay.
sharing. Then share it again. I don't know. Today it is making really a very bad thing with us. Is it available now?
No, sir.
No, sir. Yes, sir.
Nothing is there.
Yes,
Yes, sir.
That circular sector or d theta.
Yes,
X value of the element. This distance is r cos theta. For the total radius, it is r cos theta. And 2/3 of that is considered to be the x coordinate of the centroid of this individual element of this triangle. Base is r d theta and height is r. Then what about the area? Area dA of this element is half altitude multiplied by the base, half capital R d theta, half r square d theta. Is there any confusion?
Sir, please tell me 1 second, sir, please.
We are talking about this triangle. Centroid, individual centroid. The height of this triangle to find the area, it is or so area of this element, that is dA, is half multiplied by r d theta, that is base multiplied by the height. Is it okay?
Yes, sir. Yes, sir. Yes, sir.
So from that expression, we get the area of the element, and location of the centroid of this element is here, 2/3 r cos theta. Done. So once we have these two things for our integration, what we do? Simply we calculate the position of the centroid for the overall sector. And that expression finally gives us that same value, 4r divided by 3 alpha sine half alpha. Okay. You can check that expression. 2/3 r cos theta is the x value of that element centroid, and half r squared d theta is the area. So integral x dA this x is here and this is dA. So integral x dA, limits of integration minus a half alpha to plus half alpha. Now this thing, just hold a minute. Now what about the denominator of this? What about the value of that? Capital R is common, so it is half r square. And what about the integration d theta from minus a half alpha to half alpha?
Alpha.
Is alpha, so half r square alpha. What is that? It is area of this sector. Now, if we consider this alpha value as twice pi, then what about half alpha r square?
Pi r square basically.
Exactly. So either you can write in the form of this integration divided by this one separately, or whatever way you like to simplify it, that you can do. But this part is very important. You may require some time that the area of a circular sector having central angle alpha is pi r is half alpha r square, and for total angle twice pi, it will be pi r square. But for this total angle twice pi, what about that location of the centroid? It will be at the
Center.
Center of
but
the.
if it is like this, a semicircular sector, then area will be half central angle pi r square, that is the area, and the location of the centroid will be along this line of symmetry. It is at 4r divided by 3 pi multiplied by sine half pi. It is 1, so it is at a distance of
4r by 3 pi
4r
from the
by 3 pi.
y-axis.
Another very important expression. Okay, so 4r
Yes.
divided by 3 alpha and half alpha, 4r by 3 pi. For a circular arc, it will be 2r divided by alpha multiplied by sine half alpha. To find the location of the centroid for a circular sector, 4r divided by 3 alpha sine half alpha, either we can approach from this area element or we can approach from this line element like thing. Okay. Now, is it clear?
Sir, show the previous slide.
This one. 4 divided by 3 alpha sine half alpha. That is the major thing. We can extend it for different value of this angle. So either you consider it as a semicircle. This will be like this, or it is a complete circle. It is at the center of the circle. Okay, this very small thing that you can extend your common sense. Okay, But these expressions are very important for this circular arc, circular sector. For circular arc along the line of symmetry, it is 2r by alpha sine half alpha. For circular sector of central angle alpha, it is 4r by 3 alpha sine half alpha. That's all. Okay. Now, once we have this thing, let us move to some simple situation of some general figures bounded by straight lines. Okay. Now, when we need to find out the XC and YC. For our convenience, we subdivide in different segments, convenient segments. Okay. Now, but one thing, before going to that, I need to take your attendance. Otherwise, again, for this poor network quality, I'll be in trouble. It is not showing that it has been downloaded. I don't know. Okay, but I'll check it whether really it has been downloaded or not. Okay, fine. Now, next thing, where we are. Now, do you find that screen again?
Yes, sir.
Yes, sir.
So we subdivide it in suitable components like this. First one is here.
So are you moving something because it's still in our side?
I have drawn a line, a red line here.
Not visible, sir.
Is it visible?
Not
No, sir.
visible.
No, sir.
No, sir. No, it is not visible, sir.
Again, it is under that. I don't know, Bimani. Anyway, have you found that object or that plane figure with dimensions given in inches?
Yes, sir. Yes, sir.
Yes, sir.
It's all like thing, sir.
Yes, sir.
This is a problem directly taken from here and Johnston. So even if you do not get this, whatever this pen movement, just simply concentrate whatever I am telling. You subdivide in two rectangles. One rectangle is that vertical one like thing, 1 inch wide by 5 plus 1, 6 plus 2, 8 inches long. Okay, and there its centroid will be at the middle height at 4 inches. And second rectangle is the horizontal like thing. It is of length 3 inch and its centroid will be somewhere here. Now, is my pen movement is rather come back?
No, sir.
No, sir. No, sir.
Yes, sir. Now it is coming, sir.
Now it is coming. So you are getting a line of demarcation and two red dots.
Yes, sir. Yes, sir.
Okay. Now name these elements. Suppose it is element 1 and this is element 2, and individually this is C1 centroid for the area element 1 and this is C2. Now what about the distance? If it is called the origin O, then what about the distance along y-axis and distance
Sir, four,
along
sir,
x-axis?
Distance for, sir, along y-axis is 4 and x-axis is ½ inch.
So x1 is a ½ inch and y1, that is y coordinate of area element 1, it is 4 inches. This is y1, this is x1. Similarly, if it is x2 and if it is y2, then what about the value of x2?
Sir, 5/2.
X2 is 3/2,
This
sir.
is
X2 is 3/2
is
and Y2 is 5/2.
1 plus 3/2. This is
1
1
plus 5/2, 5/2.
and this is
Yes,
3.
yes, sir, 5/2.
So 3/2. And what about y2? It is 2 plus half of that width, 1 divided by 2. Simplification you do later. Okay, you do not simplify by your mental calculation. You write the expression properly, otherwise it will be, this is the foundation of the mistake, and on that wrong foundation, if you are making one building, the total thing will be, you understand what you are going to. Now, x2 is 5/2 and y2 is again 5/2. I hope so. Okay. Now, what about the area of this element 1? It is 1 multiplied by 8.
Yes, sir, 8 inches, 8 inches square.
Yes, sir. 8 inches square.
Okay. And what about the area of the element 2?
So 3 inches square.
10 to 1 inch square.
Okay. These are in square inch.
Yes, sir, square inch.
And these are in inches. It could be in millimeter, it could be in centimeter, whatever may be the unit. The calculation is numerical figure. These are important. Now, what about XC for the overall area? It will be that algebraic summation of individual first moment A1 x1 plus A2 x2 divided by A1 plus A2. And what about YC? YC is
Y1,
again
A1.
those summation of first moments of areas A1 y1 plus A2 y2 divided by A1 plus A2. Okay. Now, one thing we do normally, we do the calculation and note them in some tabular manner. And that is very useful sometime. Element, sorry. Element 1 and 2. This is area of those elements. Then the locations xi. Then the locations. I'm writing something on the screen. Is it not available there?
Yes, sir, it is available, sir.
And now it is available.
This is visible, sir.
Okay. Next thing, what do we extend this table a little further? Then we write down these multiplied values. Sorry, it should be yi. And note down them in this table. Now what about A1? A1 is 8.
Sir, 8 inches square.
And what
8.
about A2? A2
3,
is 3.
3 inches square. Yes, sir. 3.
What about X1?
Sir, half, sir. Half.
Half.
Half square.
What about Y1?
So
4,
it is
sir.
5 by 2. Y1 is a 4. Yes, sir. 4. Sorry.
Y1 is 4. For
Yes.
A2?
A2
A2
is
is
A2, X1 equal to 5 by
plus
2.
3 by 2. So it is 5 by 2. And Y2 is also 5 by 2.
yes, sir.
Next thing, we complete this table by getting the multiplication of individual area values and their corresponding X coordinate or Y coordinate. Then what about A1 X1? It is 4. What about A1 Y1? It is 32. Please go on checking this value, and if I make any mistake, just remind me. What about this A2 X2? 15 by 2, and A2 Y2 also 15 by 2. Then what about this summation?
So 23
Summation
by 2, 23 by 2 A1 X1, and it is 79 by 2.
A1, summation AI is 11. Summation
Yes, sir,
A1
yes,
X1
yes.
is 23 by 2. Summation AI YI is
79 by 2.
64 plus 79 by 2. Now you can calculate it in the form of fraction or in the form of decimal, but for the time being we keep it. If by any chance there is a possibility of cancelling out from numerator denominator the same term, we can get those facilities. Next thing, XC, summation AI xi over summation AI, that is 23 by 2 divided by 11 inches. And what about YC? YC is summation AI YI, that is 79 by 2 divided by 11. It is also 79 divided by 22 in inches. Now, for these two elements, our mental calculation is more than sufficient. But for more number of elements, it will be very difficult to keep track for all such individual values. So for that, extending this table will be very important. For suppose 8 elements are there, so I for 1, 2, 3, 4, etc. corresponding area values. So if by any chance you make any mistake, it will be easier for you to locate that particular component where you have made that mistake. Okay. So
Yes, sir.
this is the way how we do this thing, and we can extend it for this one. Next problem. It is looking like some inverted triangle. Now it is not symmetric. There is no vertical line of symmetry, as well as there is no horizontal line of symmetry. But one thing we know, that is, if it is the middle point, at how much distance?
Sir, 15 millimeter. No, sir, no.
30 plus 48,
30
78.
48 by, yes, sir, yes, sir.
78 divided by 2, that is 39. And if we draw a line connecting this vertex and this middle of the opposite side, so this is the median, and at 2/3 height there will be the centroid along this median,
Sir,
Okay. Yeah.
so we can assume it to be the full rectangle and then subtract the area of those two right angle triangles as well.
Definitely. Why not? There are so many methods. But just to start with, we will discuss about this preliminary information. Now, one thing is sure that from our primary ideas, this length along this median is subdivided in 1:2 ratio. So naturally, this height is also in that ratio of 1:2. So what about this YC? Is it not 48 millimeter? Two-thirds of 72.
Yes, sir, it is.
Okay, but XC is different. Okay, so to get the value of XC, we do this thing. Let me erase all these additional information. Otherwise, it will be confusing for us. Okay. Now you just subdivide the triangle in two parts. Base of these two individual triangles. This is 30. This is 48. Now, what about the centroid? It is at 1/3 distance from this vertical line used as the base of this triangle, a right angle triangle, and here at 1/3 distance from this red line base. Okay. Now, what about x1 if it is called as 1?
No, sir, couldn't follow because the screen is lagging, sir.
It was something like one inverted triangle. We subdivide the triangle with a vertical red line. We consider two elements now, small triangles. The left one is 1, right one is 2. Now area for the element 1 is half multiplied by base, that is 30 multiplied by, what about the height? 72. And area of the element 2 is half multiplied by 48 multiplied by 72. It is C1. This is C2. Now this distance XC1 is 2/3 of 30, that is 20, and XC1, it is X1. Please make this correction. X1. And what about X2? Can anybody tell me quickly?
Sir, 30 plus 48 by 3.
30 plus 1/3 of 48.
Yes, sir.
Okay.
46.
And what about Y1 and Y2? Definitely those are 48 and 48. So regarding that thing, as the base is a straight line flat parallel to x-axis, so YC is 48. It is done. Okay. Only thing for XC. Now for XC, we'll do that same thing. XC is A1 X1 plus A2 X2. Put them in that table. A1 plus A2. You get it? Now I come to that part. Somebody was asking for what about that way of doing this thing. X-axis, Y-axis. Original diagram was like this. Now, if we consider that it is equivalent to that rectangle minus this triangular part minus this triangular part. If it is 1, if it is 2, if it is 3, then area of elements 1 is 70, the 30 plus 8 multiplied by 72. Element 2 is half 30 multiplied by 72. Area of element 3 here. (48) multiplied by 72, and ultimately you have to write this expression in this way. XC is A1 x1 minus A2 x2 minus A3 x3 divided by A1 minus A2 minus A3. If you don't make any mistake, you are supposed to get that same result by whatever you have received from your previous method. Okay. There may be other way also.
Yes, sir. We just
So,
taking the area as a negative area.
And x1, x2 are determined from this.
Yes, sir.
This one, x1, y1. Here it is x2, y2. Here it is x3, y3. Okay.
Sir, one doubt is
yes.
there.
Which doubt?
Sir, C2. Sir, 30 plus 48 by 3. Why it is not 2/3 of 48? Why 1/3 of 48?
What for the previous case?
Yes, sir.
Sir, we have a class, sir, from 12.
Okay. This is 30. And this is 1/3 of 48. Is it okay now? So you have a class, so kindly leave. Okay. We'll continue in our.
Thank you, sir. Have a nice day, sir. Thank you, sir.
Thank you, sir. Sir. Hello, sir.